Founded in 1943, the mission of the International Magnesium Association is to promote the use of the metal magnesium in material selection and encourage innovative applications of the versatile metal. IMA's members consist of primary producers of the metal, recyclers, foundries, fabricators, end users, and suppliers. The global voice of the magnesium industry, IMA serves the industry and its membership through its annual World Magnesium Conference, which this year is in May in Fukuoka, Japan. Seminars, statistical programs, research, and publications. Through IMA's efforts, manufacturers and consumers are increasingly aware of the numerous options and benefits that the metal magnesium provides. This webinar will be a roundtable format. We have some questions that the speakers will be answering. If you have a question that's related to the topic, please feel free to ask on the Q&A tab you'll see at the bottom or the right-hand side of your screen, depending on your layout. If there's a chance the speakers will be able to answer your questions, and if not, if they don't have time during this webinar, we will follow up with you after the webinar. Now to introduce our speakers. Anil K. Sachdev, give a little wave, Anil, retired from General Motors Global Research and Development after serving there as Principal Technical Fellow and Lab Group Manager at GM. Dr. Sachdev is a member of the National Academy of Engineering and a Fellow of the Metallurgical Society. He started his career in 1977 after receiving his doctorate in materials science and engineering from MIT. His research interests included microstructure design of aluminum and magnesium alloys, metal matrix composites, and high-strength steels for structural applications. The various projects he led were focused on improving performance of materials and designs to reduce component mass for improved energy efficiency. Most recently, he led materials developments related to additive manufacturing and lithium metal for battery anodes. He has presented several keynotes at international conferences and has been a key reader for metallurgical and materials transactions for the past 40 years. He has 120 patents and 100 plus external publications related to light metal developments and has received Best Paper Awards and Product Recognition Awards from AFS, TMS, NADCA, and IMA for his work. Let's see. Okay. Dr. Elmar Beeh, give a little wave, thank you, is head of the Department of Materials and Process Applications for Road and Rail Vehicles at DLR's Institute of Vehicle Concepts. With his group, he is working on lightweight technologies, considering the improvement of sustainability along the full value chain of materials. Dr. Beeh is the organizer of the annual conference Werkstoff Plus Auto. He is a member of the IMA Board of Directors, and since 2021, he is leading the IMA Sustainability Committee. Now we have Abey K. Abraham. Abey is a managing principal at Ducker Carlisle, where he leads Ducker's automotive and materials practice, specializing in transportation, mobility, and electrification-related client needs. Abey holds a Bachelor of Science degree in psychology from Michigan State University. He has over 18 years of experience in the automotive materials space, understanding key drivers and strategic elements of lightweighting, material substitution and joining, and expertise in metallic and non-metallic materials. Clients value Abey's expertise and leadership in pursuing growth strategies, organic and inorganic, to optimize solutions to address dynamic mobility and lightweighting trends and its supply chain. He serves on the board of directors of the Society of Automotive Analysts and is on the editorial advisory board for Lightweighting World magazine. He is also an active member of the Society of Automotive Engineers. And then a quick note about myself. I am Rose Eaton. I am the IMA America's representative, and I am also associate publisher for Light Metal Age magazine. Okay, now to get to our questions. So, as you may be aware of, there have been recent disruptions in the automotive industry. This roundtable will explore these disruptions, chips, COVID, magnesium supply, gig castings, transition to EVs, environmental concerns. All these things affect the magnesium market. We'll explore these disruptions, their effects on the market, and the future of magnesium in automotive applications. Please ask questions in the chat as the discussion is ongoing. We will try to address this in the discussion or through follow-ups. So to begin, our first question, and this is for Anil to start. What are some of the impediments for magnesium applications in automotive?
Yeah, hi, can you hear me okay,
Yes.
Rose? Okay, great. So, we break that into two categories. One is the obvious category, which is, we need a stable domestic supply base. And with all of the, supply chain issues that happen, geopolitical issues, etc., not having a stable supply base in North America is an obvious impediment that comes when we try to make decisions to use magnesium for various applications. The next is a stable pricing structure to allow us to make good projected decisions. And these fluctuating prices because, of captive supply bases does not help the situation. So these are some of the obvious things that come to mind right in the beginning. The next high-level factor is a design of the product that drives a compelling choice. And here, I want to bring a comment on the word sustainability. So while there's going to be discussion on sustainability, but there's one facet of sustainability, which is that once you make an application in magnesium, it should be so compelling and so strong that going back to the prior design is not an option. And that is a facet of sustainability that we don't talk about other than, the obvious ones we will discuss later in the talk, in the discussion today. And if you look at other industries, for example, aluminum industry, and it's good to compare with alternate materials. All our engine blocks are now aluminum and we'll never go back to cast iron because it drove a compelling choice. And same goes for many applications you can look around that got displaced and we will never go back. So that is a very important factor in making that choice. And one approach that does not help is when you try to make a one-to-one substitution. So you got something that's made in aluminum and you make a direct copy in magnesium, and that generally does not become a sustainable solution. So you need to exploit the advantages of magnesium to give you a compelling design that meets all of the various attributes. Now, these were the high-level factors. You get to the engineering factors that come into play. One is corrosion mitigation. Magnesium is a very active material because it does not have a strong oxide, natural oxide like aluminum. So you need to have some augmented corrosion mitigation, especially to use in wet areas of the vehicle. And this adds cost and complexity to the component. But again, if you make a sustainable, compelling design, you can work around this. Next is joining. And generally, magnesium will get joined to something that is not magnesium. And these multi-material joints are very hard to manage. They can be managed, but this is something that you need to consider. Then there is tolerance to fracture, which makes it very difficult for magnesium to be used in load-bearing, high strain rate situations. And so, improving fracture of magnesium is very important. Strength of magnesium is generally not an issue. In fact, in some applications with the right alloys, you can get the strength you need without having to do a heat treatment, and that's a huge cost saver if you can do that. Next becomes the qualification cost. These components have to be totally qualified for the application. So if you don't have a high volume change, the cost of the qualification does not allow you to justify the change. Now, finally, all of the engineering is moving towards virtual engineering, which means we need robust CAE analysis of the various magnesium alloys in the various magnesium applications. And that actually becomes a huge factor when engineers are trying to apply magnesium for a particular component. And the analysis is improving, but it is not as robust still as some of the established materials, although it is very, very good, and we do use a lot of magnesium in various applications. Thanks, Rose.
Thank you, Anil. Was there any other panelists who wanted to answer that question, or shall we move on?
I maybe want to add one more comment. I think Anil covered all of it in detail. The other is we've been tracking the materials base as it relates to the automotive applications. And to Anil's point, there's been a lot of mixed material vehicle applications, right? So when you look at the application for magnesium, there's going to be singular components that could take advantage of magnesium. But in a lot of instances, in the body in white, you're joining it with mixed materials. And so we've seen that magnesium, when it's working hand in hand with an aluminum component, for instance, so for a door inner or a closure inner that's made out of magnesium casting and an outer that's made out of aluminum, there's benefits and advantages that we could take advantage of, right? So, but as you look at it from a standpoint of the steel content in vehicles, particularly in the structural applications, there's a lot of applications where the magnesium component has to coexist and join and interact with a non-magnesium part, if it's aluminum or steel in a lot of instances, right? So we have to consider that from a corrosion standpoint, but also from the joining standpoint as well too. So that's something I think from a standpoint of the metallurgical sciences that we need to, continue down that pathway to show better integration and show how and demonstrate how these things can work together in a proper manner as well too. And that falls on not just the OEM, but also from the supply side as well too, which is probably another question that we're going to address here, but just want to kind of add to that point.
Maybe I can also add something from our research standpoint. So we have been doing a lot different developments in magnesium in the last about 20 years. If it has been complex castings or extrusions with crash properties, where we used magnesium also for energy absorption. Even if it was complicated, we developed simulation models. So all the topics Anil mentioned are completely right. Magnesium is not the material where you can say an unexperienced designer which have it the first time in his hand will develop the best solution at the very first time. So it's a material where you need a little bit of, or not only a little bit, you need to have a sympathy for it. You need to have a experience maybe, and also maybe some, let's say, advisory or consulting, how to use it and how to design it. But all the different points what Anil solved beside the stable pricing and the stable supply are solved technically. Yeah, we have the solutions for all those problems. The only problem what we haven't solved yet, because of the strong dependency from, let's say, one major source in the world, is the stable pricing and the stable supply.
Thank you very much, Abey and Elmar. We do have a couple Q&A from the audience. Can the speakers see those questions as well? Okay.
Yes.
If are there any questions so far that you feel go with this, or shall we keep going with the listed questions and see if we cover those along the way?
I think we'll be covering the magnesium content in vehicles coming up here, so we could address that in a follow-up question that's coming up here.
Okay.
Yeah. Also, I can add a little bit about a recycling topic later on.
Okay.
If we don't cover it in our following questions, we come back to that.
Okay. Thank you. And thank you to the attendees for putting questions for the speakers. Our next question is, with most of the OEMs, we hear supply stability is a major obstacle for the future use of magnesium. What needs to be the base of a reliable long-term supply situation for magnesium? And Abey, you can start us off.
Thanks, Rose. Great question. I think Anil touched on a lot of the key points in terms of the background here, but I can't stress enough the supplier diversity piece here, right? OEMs in general, any automaker, anybody that's making a part doesn't want to be beholden to one supplier. So having a diversity of supply base is very key, particularly since the COVID pandemic. It really demonstrated major cracks in the overall global supply chain, right? You've had parts that were stuck at ports, parts that were stuck in the ocean. So we really need to make sure that from a supply standpoint for the parts or components or systems that are going to be designed with a magnesium casting particularly, has to be somewhat localized, and we need to find more suppliers that are willing to take that on. Broadly speaking, we've seen a resurgence of localization and nearshoring and reshoring, but it begs the question of which supplier has the right metallurgical expertise to take this on, right? So the OEMs are doing their own research and background, but they've turned to the supply base to bring some innovation, to bring some capabilities of how do we, best utilize the strengths of magnesium in the applications. And second, I think part of this webinar and what the International Magnesium Association is doing is to collaborate with the supply base to educate more of the OEMs and parts makers on the magnesium advantages and benefits, right? So there's a lot of tribal knowledge in terms of, it's once, if there's an issue with it, it's uncontrollable. The corrosion points, as Anil has mentioned, there's different ways of best utilizing the material for certain applications, right? So maybe if it's exposed to the environment, we don't use that. We don't use it in that application. We use it in for some other applications like a seat inner or the door inner where it's protected. But there's ways for the supply base with the International Magnesium Association to work together to educate. And I see a lot of that happening if you look at other industries like the Aluminum Association, the American Iron Steel Institute. There's been a lot of work that's been done and different working groups that have been set up. And I think that the association here has some work ahead of it to kind of make sure that we're doing that to illustrate and show the applications and how we could have more success stories with magnesium. And I can't stress enough the raw material availability and stability on the value of magnesium. The industry has to reduce that volatility in the raw materials, including where it comes from, the tariffs that are put on it, right? Expanding that out, but also working with the U.S. government and the Commerce Department to make sure that there's fair practices in place so that the availability of that raw material is an impediment for that, right? And I know we're going to come into some of these points a little bit later, but automakers hate when you have instability in pricing, right? So when you're selecting a material, you need to know a somewhat stable level of how much this part's going to cost from day one, or from a pre-production standpoint to production to end of life, and even after the vehicle is done, you'd still need service parts, right? Obligation period of parts. So that price stability has to be there. Suppliers, unfortunately, are in a situation where they have to pass on raw material costs, right? There's a certain percentage that they could kind of absorb as well, but fundamentally, you have to pass that on to the OEM or the customer, and that doesn't really work well when you're making hundreds of thousands of vehicles over a 5 to 7 year period, right? So I think those are fundamental obstacles in terms of long-term supply situation for magnesium and how I kind of look at it. And I know we're going to cover some more of the topics as it relates to the parts and the content coming up here.
Okay, if there's no more comments from the other speakers on that question, we will move on. What is the biggest issue confronting more magnesium adoption and utilization in the automotive industry? Part of it may be what Abey was just talking about.
Yeah, and I'll kind of piggyback on that first comment, and Anil and Elmar, please add into this. The applications that we currently have for magnesium are pretty numerous, right? From wheels for high performance type applications of vehicles to structural reinforcements like a radiator support that we see in a large pickup truck that's on the market today, door enclosure inners down to tiny precision cast components that we're seeing in electronics, right? So there's individual components, there's components that are part of a system. Actually, today in the vehicle, in the average light vehicle produced in North America, there's about 16 pounds of magnesium in 2023, which is expected to grow. Besides the direct applications of magnesium that I just kind of illustrated, there's also the overall effect of magnesium demand that's used in the production of aluminum itself, right? In its various forms. You need magnesium for the casting alloys, for the ingot that's turned into sheet, for the billet that's turned into extrusions based on the specific application. So you're competing. The supply chain is limited to begin with, but now you're also competing with a material that's required for automotive applications, like how Anil had mentioned, right? The powertrain in a vehicle right now, the engine block and head transmission cases, those are all, heat exchangers that all went from brass to copper to aluminum, or cast iron to aluminum. And so there's a lot of demand that's also competing for the individual parts themselves out of magnesium, but also from an alloying perspective that's required to produce aluminum that goes into this as well too. As I kind of touched on before, once a supplier is selected for a given part, if it's steel or aluminum or magnesium in this case, the parts have to be supplied on a very choreographed dance. There's no room for error, and any error means major dollars as an implication. If you have to shut down a plant or have to source parts from somewhere else because the supply chain is altered, this is an impediment, right? We need to make sure that the suppliers are capable and there's enough suppliers in case there's something happens, there's this backup to supply this. Prices are negotiated up front. Sure, there's escalation clauses that get mentioned, but there's risk for price. If there is a risk for prices to spike, and that could lead to supply shortages, alternative materials are often evaluated hand in hand, right? So as Anil mentioned, right, there's parts you can't look at it from an apples to apples comparison, right? There's a part that we have an intended application for magnesium, but in a lot of instances, when it comes to magnesium, the design engineers and the OEM or the suppliers also have to think about it from a standpoint of in the event we're unable to get this part, can we substitute it with a composite, an aluminum or a steel stamp part or solution? But that also falls into the overall decision matrix of what materials to select, and all that as well too. In terms of the other ways to reduce the risk, it's the volatility in the raw materials, like I mentioned, right? So there's that, and the supply side as well too. I think those are two things to address there. But I'm curious to hear what Elmar and Anil has to say on this as well too.
No, I think you covered it well. I don't have any more comments.
Yeah, same for me. I think there are many other questions, and we have covered the supply topic quite well. And also the options where to use magnesium. We will come back later on, I think, a little bit on this topic. Yeah.
Okay, and that leads us into our next question. And this is to Anil first. What are the most important considerations for auto industry participants in moving from steel or aluminum to a competing product like magnesium? And also, we have a question in the Q&A which you may be able to address that goes along with that, which asks if magnesium is competing, as seen in some BMW models, with other multi-layer materials, such as glass, carbon reinforced plastics.
Right. You see, material choices are very complex decisions, and sometimes the decision could be specific to the OEM based on what their infrastructure is today. Do they have to put new infrastructure, etc.? So the decision is not just say density. Magnesium is 1.7, aluminum is 2.7, so you should use magnesium. There are a lot of other factors that come in. So the way I always look at magnesium implementation compared to other materials is I come back to the compelling design and compelling application. So magnesium should bring you the advantage, the obvious advantage. It is lightweight. Okay, so we get that, right? The other advantage is, does it, say, for example, allow you thinner walls compared to other alloy, to other materials? Does it allow you lower draft angles? So sometimes, looking at polymers, to get the same stiffness, you need thicker sections. And, dimensions are very important in automotive applications because space is always a premium, and sometimes we fight over millimeters of space. So thinner walls, lower draft angles. For example, can magnesium allow pre-threaded holes in the castings, which you cannot get in other materials? And can you make more complex castings, considering that magnesium has such good flow properties in a die casting? And so it should allow you to have better part consolidation. So one of the areas where magnesium has always been a prominent choice is in the area of part consolidation that gives it the winning play. And one such example is the instrument panel beam, where you combine 30, 40 parts into one or two parts. And that gives you tremendous dimension tolerances, and notwithstanding the other factors that we have mentioned about supply base and so on and so forth. So if those stabilized, this could become a sustained application. If you take, for example, a sustained application in magnesium is steering wheels, and that you are able to make such a wonderful design with the steering wheel and take advantage of its damping properties, that now we will never go back to how they were made with other materials, and it just stays. So basically, it's not just a question of one attribute that allows the decision. It is a combination of attributes, and I will reiterate that it combines. The decision is made on how well you can make do the part consolidation. That is so important. And with part consolidation, can you maintain the thinner walls, because now you have to flow the metal to longer distances, and magnesium allows you to do that. The other area where magnesium is very helpful is a physical property of what we call latent heat of fusion. So less heat has to be extracted when the casting is made compared to, say, aluminum. And that may give you an advantage in die life and so on and so forth that you could take advantage. So in the end, I made several comments and putting all of those together and pushing on each of those buttons will start to bring magnesium closer and closer to a sustainable application.
Yeah. Anil, thank you. I like to add one point from a technical side. So magnesium have competed, if we compare it with the other metals, it has a quite better damping property, which helps also on the NVH area to, and also when it comes to, let's say, feelable vibrations where magnesium has better properties in some applications. That's also the reason why it's very useful in the steering wheel and the instrument panel carrier application, where you have also vibrations what the driver is feeling or can feel. So applications like this, or also a gearbox housing where you have high frequencies which need to be damped, and noise should be cancelled, and there magnesium can also have benefits. And one topic, one comment on the question from the chat regarding the fiber reinforced plastics. We have been thinking that magnesium will see more acceptance through the trend what we saw about 10 or 8 years ago, that fiber reinforced plastic coming in, but the benefit compared to the magnesium regarding lightweighting was not that strong. But magnesium is much better when it comes to recycling, when it comes to, let's say, higher volume production. And so at the end, we did expect that when we see the trend of increased use of fiber reinforced plastics, then it will end up in a trend that more magnesium will come in the next step, because they will go back to magnesium. One challenge here is that the trend to carbon fiber plastic is gone. Yeah, so there is no trend anymore. All the premium car manufacturers, beside the sports cars, have gone away from those. It's only used for the very small volumes like before, and so we see in Europe that this trend is not stable anymore. There is no trend. It's more trend to going back to increased use of aluminum. But therefore, let's say this chance is gone for magnesium at the moment. But that has also to do with the unstable supply chain. So, but there is not really a competition at the moment between the fiber reinforced plastics and the magnesium as we see it in Europe.
Yeah, if I could just add one other softer point, is that if you look at the other materials, there's typically a good set of knowledge base and champions at each of the OEMs. in terms of adopting, researching, and kind of accepting and bringing in certain materials and suppliers to that OEM. I think the industry as a whole needs to work with academia, as well as the OEMs, to make sure that engineers that are starting up, I mean, a lot of folks are very comfortable with steel and the different grades of steel and how to kind of, form them and put them together. Aluminum knowledge is also increasing pretty rapidly there. But I think from a magnesium perspective also, we need to start probably educating and providing more use cases and examples earlier on, so there's a level of comfort for new engineers, so that they could bring that with them to their respective organizations, if it's an OEM or supplier as well too.
Thank you, panelists, and thank you also for addressing one of our questions from the audience. Moving on. Discuss the global versus local sourcing situation and what implications this may have on the auto industry. Some global OEMs require to source their raw materials locally.
Yeah, maybe I can give some insights what we are discussing in our, not only on the sustainability committee of the International Magnesium Association, but also on other committees or in the board. So what we see is the diversification of the supply chain. The global diversification has started, but we will have we need to wait for another, let's say, 2 or 3 years before new players are coming to the market. So, but this is something which is going on. We have several initiatives in Europe to locally produce primary magnesium here. We also know about new projects in the US, which try to build up new, also with new, more sustainable processes, that they build up new production facilities. We also, I've been visiting last year 2 companies in Australia, which are also helping to diversify the supply chain. When they get well, let's say, will be operable. So there is a move to diversify the supply chain, and this will help, but it will not perfectly help today. It will help within the next years. And that's important to know, that we all see both. We see not only new facilities which are coming up. You all might know that magnesium is one of the most abundant materials in of the world. So you find it almost everywhere in the world. But to find a way to process it in an economical way, in a competitive way, and also on a basis of green energy usage and greener processes, that's what the industry here in Europe is asking for. And that's something which is addressed by several companies, and we have the strong wish that they will be successful, because that's important.
Yeah, maybe just to add, to piggyback on Elmar, with the USMCA and the Inflation Reduction Act, IRA, there are some implications, particularly as we get into more of the electrification or the conversion from ICE to EVs, that require very specific amounts of localization, particularly for batteries and the battery housings and the components around that. But ultimately, the more that I speak with OEMs and the suppliers, is that a major effort to, really localize the sourcing of parts and materials where the vehicle is produced, right? So if the same platform is produced in multiple parts of the world, either the supplier has to have a global footprint, or that level of availability of material needs to be there, right? So if a magnesium part supplier is abundantly available in the Asia market, and that same vehicle is going to be produced in the US or North American market, either that supplier has to have some footprint here, or that availability of material and stability has to be here as well too. So I think those are some other aspects that, from a standpoint of local sourcing, that's also we got to keep in mind.
No.
Thank you. And I know as well at least here in the United States, the Department of Energy and Department of Defense are funding some startup companies that are looking into more environmentally friendly ways to produce primary magnesium back in the United States again. So it's a very exciting time for magnesium. Our next question, to take a little bit of a turn, and this will also answer one of the audience questions. How much of the metal content of a typical car could be magnesium if supply wasn't an issue and price competitive?
Yeah, I'll take that one. I'll start that one off at least. Crystal ball question, of course, but always tough to answer. But we've tracked the various material content in vehicles for the past couple of decades, primarily focused on steel and aluminum because given its higher share of the content of the different material types in the vehicle. But I could tell you from a direct magnesium content perspective, most or if not all is cast in the vehicles in North America today is about 16 pounds per vehicle in 2022, 2023. 18 pounds per vehicle is our forecast for 2026, and about 21 to 22 pounds per vehicle in 2030. That's a base case. That's given all the conditions that we know about magnesium today. Now, if you take out all the impediments, right, and Anil talked about the advantages of magnesium, it's lighter, typically on an apples-to-apples comparison compared to aluminum or steel. It's obviously has different strength characteristics that are more advantageous than the other materials. From a forming process for the actual dies and the equipment itself, it's a lot easier. So you've got, you could have a lower cost of the actual equipment to make the parts out of as well too. There's a lot of advantages there, but if you look at the aluminum HPDC content, right? Again, I hate to kind of use an apples to apples comparison, but that's the base reference case is that there's about 120 to 125 pounds per vehicle of aluminum HPDC in the typical average vehicle today. Some will have more, some will have less. And that includes some of the structural big parts that we're talking about from Tesla and some other OEMs that are starting to implement some of those solutions as well too. So can we take all 120 pounds away from the aluminum industry? Probably unlikely, given there's specific other issues with corrosion we talked about. But that's the bogey. At least we know that there's a typical vehicle can have up to 120 pounds. And currently the magnesium content is only 16 pounds. So at least we know what the runway looks like. And that really depends on the industry. If you look at the aluminum industry, again, for that cast components, there's hundreds of suppliers for cast aluminum components in the US, Canada, and Mexico, right? We got a handful of magnesium cast component suppliers in the US in the North American market as well too. So there's comparative differences, but again, if you remove all the roadblocks and barriers, at least we know that up to 120 pounds per vehicle is the bogey. It's the target of what the magnesium supply base could think about.
So, one important comment to make is, fortunately, in a competitive product, other material industries do not stand still. And, their developments are constantly evolving, and they are very compelling. For example, you take the giga castings today where, technically you could make the entire vehicle in a few parts and displace steel. But for magnesium to come into a structure that has to meet, requirements that are very, very stringent, at the moment, unlikely, even if I had all the magnesium available. So in the end, the decision is a very multifaceted decision, all the way from availability to the engineering factor. So if we look at where magnesium could start to make some headway. One, I see a lot of opportunities as we go into electrification. So magnesium has some unique EFI properties that we can exploit, which means, I can see a situation where, most, if not all, electronics housings could be made out of magnesium. So in addition to lightweighting and exploiting the complexity of these housings and the ability to make thinner walls, it's a ripe area for magnesium to actually push into those areas. Another area that I have actually spoken before is in mixed material designs, where you make the component as a mixed material solution. So for example, overcasting magnesium on, say, aluminum extrusions or steel tubes, where you keep the simplicity of the application, as a tube, and as an extrusion, which is much better in steel and aluminum. And then you overcast the extremely complicated portions of the application with magnesium, because that allows you to do that. So for example, even though we can make the IP beam in one piece today, there's no harm at exploiting IP beam with magnesium overcast on either steel or aluminum, and it could give you a better solution. Then you look at, sometimes we look at automotive applications. Today it's on automotive, but sometimes you can work the non-automotive side and improve your technology and then bring it into automotive. So you come in a roundabout way. And one area that I think where there could be a great opportunity for magnesium is in drones. And there, lightweighting is paramount. It's absolutely paramount. Also, with the large format castings that are becoming available today, one could see making the entire drone in between 2 to 4 pieces and putting it together, and with a lot of complexity on the inside as well. Now, once, say, this is non-automotive, but if this can be perfected, then a lot of those learnings can translate into automotive. So sometimes you bring automotive applications from other industries, and it's not all bad to do that, because it just gives you another path to increasing the application of magnesium.
Okay, thank you, Anil. Our next question is, what are some new opportunities for magnesium usage within the framework of the mobility transformation? And this is to Elmar.
Yeah, I think many of the many answers of this question have been given by Abey and Anil, also related to the last question. But I like to add, what we see is that the typical area where magnesium has been applied, also in the combustion engine, let's say time, for example, in gearboxes, where it has been applied quite successfully. This can be also transformated into the electric drive era, because the housing of the electric drive is comparable to a gearbox from the let's say from the load case, from the also the requirements regarding corrosion resistance. And so we see a huge potential when all those things what we mentioned before, local sourcing, lower CO2 footprint, stable pricing will come up, then it's quite easy to apply magnesium again in applications like that. I say this also because we see that those applications will come up quite fast in areas where you don't have the supply risk. In China, we see those kind of components. We see also large castings there, and we see that they applied, let's say, quite intensive and without the, let's say, impediments in mind. They use it because it's available. And so from a technical point, there are many opportunities. And what we also think that it's beneficial is that the transport sector, the complete transport sector, like in the smaller and heavier transport vehicles, where you have the rack systems, for example, for the mail transport. If you electrify those transporters, then weight and the utilizable load capacity is a very important factor. So we see applications there that they use extrusions intensively to reduce the weight of their vehicles to increase let's say the usability of those vehicles. And their magnesium is also a very good material option.
If I could just add to what Elmar is saying, great, awesome points. And, you know, it's really taking advantage of the natural strengths of the material, as we had kind of talked about before, if it's the strength, the stiffness, the heat dissipation capability. So I think for electronic components, if we look at the average content per vehicle of electronics, it's proliferating pretty tremendously, particularly when we get to electric vehicles as well, too. So we have to take advantage of the material's capabilities and try to design in as many parts that could take advantage of that, and in the mixed material format, right? So if it's the housing base could be a cast aluminum, but the top cover could be made out of a magnesium casting, or the vice versa. But there's also the innovation and competitive dynamics as well, too. So we've used magnesium castings and instrument panel supports based on specific requirements that a typical ICE vehicle has in terms of torsional stiffness that's required, side impact protection as well, too. But as more materials are innovating, we're also finding some of the EV manufacturers stepping away from having a large casting there to using more of a simplistic extrusion out of aluminum, and then using some type of composite or plastic for specific brackets that are required to mount certain things to. And that's purely because the design of the vehicle itself from the inside is changing, right? So I think you have to start thinking about it from Anil's point, is that we have to find unique applications and really build the value proposition for magnesium for those applications. But we can't do that in the void, considering that other materials are not going to sit still. They're going to be innovating. They're looking at obvious ways to kind of displace the cost that comes with from using magnesium as well, too. You know, there's also applications that we already know. It's seat frames, anything that's in the interior of the vehicle that could take advantage of that lightweight. As we move to more EVs, this will become really, really critical, because it's a range consideration. I think there's another question that's coming up that we could tie into this, but EVs really need better efficiency, but it's also balancing that with the cost of the EV as well, too, right?
Okay, thank you very much. Just a housekeeping reminder, we have about 15 more minutes for this webinar. Any questions that we don't get to from the audience, we will try to follow up with you through email afterwards. And some of these questions we may have already touched on our planned questions. So panelists, if I ask a question you feel that has been significantly answered, please let me know. Or if I skip something that you think is important, please also speak up. Moving on to as more automakers are transitioning to more aluminum use beyond just castings, do you see this easing the path for magnesium?
I think so. First, sorry, I'll jump in. I think so. Like as Anil had mentioned, I talked about magnesium and aluminum tend to work well hand in hand, right? So I think there's a compounding effect there. If you're using aluminum, you've already kind of understand there's a cost associated with each pound that's saved. That's an equation that every OEM has their own DNA towards, right? For a sports car, there's a higher threshold for saving more, spending more to save more weight. And that's already been kind of addressed and understood from the aluminum standpoint. So magnesium has as a positive effect there.
Yeah. So I'm not sure if I really be that optimistic there, because there is not really a huge change in the technical requirements. So where have magnesium been successfully used before? So it's more like on the hang-on parts area. Yeah. If you have a hang-on part, you mentioned a seat frame, we mentioned an IP instrument panel carrier. We mentioned, let's say, the steering wheel, gearbox. That's something which is not too complicated to integrate. But when it comes to the vehicle body, and when it comes to, for example, the giga castings, they are typically today mentioned as being part of the vehicle body. And we haven't seen magnesium parts in the vehicle body yet. We have seen it as a hatchback or something like this, which is hang-on part level. And the reason hasn't been changed that much. So I know about activities also in China where they do work on large magnesium castings, giga castings, for example, to make a battery tray from magnesium. And it seems to be a logical step, yeah. So, but I'm not sure if when it comes to the vehicle body, if we are on a point that this is the, let's say, I think there is much more, let's say, long-hanging fruit to be harvested before we see it being integrated into such vehicle body applications where we typically have the giga castings. So don't know, we will see it, but there are maybe that's my feeling there.
Okay, and I've had a suggestion from a panelist to answer some of the attendee questions. We actually have about 8 open questions right now. Elmar, would you like to start by choosing one of those questions and answering it?
Yeah, maybe I'm going to start, let's say, with the very first question from Romain Billy, or I don't know how to spell it, but the question was about functional recycling of magnesium. That's a very important point. To be honest, the recycling topic for magnesium is not well solved, especially when I talk about the European situation. I don't know if it's better in the US. The challenge what we have there is technically it's quite easy to collect and to sort magnesium, but many portions of the magnesium scrap today end up in mixed aluminum scrap, aluminum magnesium scrap, and then it will be used maybe for aluminum alloying, which is also not bad, but to use it directly for new magnesium products is mostly done with the pre-consumer scrap from the production. There we see it that the scrap ends goes back to the production, but when it comes to end-of-life scrap, it's getting quite complicated. We have applied for a huge project and we got the funding decision last week to directly take care for this topic here in Europe and look how to better sort and collect magnesium to make it available for the industry, because it's really a hot topic also to reduce the CO2 emissions of magnesium with higher recycling content. Yeah.
So there's a bunch of questions in the chat. Maybe I can address them together. There's a question on, is gigacasting a threat for magnesium? Magnesium for battery trays, and China working on gigacasting with magnesium. So there's one very interesting scenario when you are working on high volume material, which is increasing the application of magnesium in other industries actually helps the automotive, because it increases the volume of availability of magnesium. That's number one. When you look at gigacasting in aluminum, it actually opens the door for gigacastings in magnesium, because now you are developing a supply base that can make large die castings, that can make large dies, and plants that have the crane capacity to handle large dies, etc. It helps all materials and not necessarily the material that you started with. So when you come to the specific application, it becomes a competition between the materials that are available. And then, like I said earlier, that competition is addressed by the key requirements of the particular components. And some components will be very difficult to displace and use magnesium, but some, they have a very good opportunity now with other industries and other materials opening up the opportunity to use magnesium. So for example, gigacastings, once that industry opens and you have more availability of making gigacastings, then looking at large magnesium castings makes it a less of a hurdle. So for example, it is conceivable that most of, for example, your rear lift gates, etc., could be magnesium, because that's where lightweight is a big factor, because of the spring that you work against when you close the lift gate, and the motor, in the case of automatic, the motor becomes smaller, etc. So you have several advantages of using these large format castings in certain parts of the vehicle. Now, whether it could be made, whether you could make a battery tray out of it, you can make the casting. That's not really the constraint, but there are several requirements, and one of them is actually road debris that can hit the underside of the battery. And now if you have to have a separate load mitigation system, the cost then really goes up, which means you have to come up with very high toughness magnesium alloys that can withstand that particular situation. So in the end, as the industry is moving and different materials are driving different approaches, they all actually surprisingly help each other. And for example, non-automotive applications, increasing non-automotive applications actually helps automotive applications, and vice versa, because it makes the material more and more familiar to the engineers who design with the material and also look at its particular application. Now, the next comment I want to make is on the sustainable supply of magnesium and any of the threats associated with that. Sustainable supply is very important. Today, for example, most of the magnesium is made from a thermal process, which is actually not very desirable. And we know, for example, the government is sponsoring a lot of work and effort on trying to make magnesium from sustainable raw material. For example, a company in California, Magrathea, is looking at saltwater types of sources for making magnesium using sustainable electricity sources. And when you combine the two, you could, in a way, in the end, have a much lower, perhaps a negative carbon footprint to make the magnesium. And that will appease a lot of engineering decisions where you can apply magnesium that comes from very, very sustainable source. Opening that up creates a competition between various forms of magnesium. And if you can make the metal cheaper and better, that helps. So I think when I looked at all of the questions, I tried to address them in one comprehensive way rather than one at a time. But I know we are kind of coming to the end. I'll just make my closing remarks, and maybe others can close on their remarks as well. We need the sustainable supply base. We need very smart engineering. That's really the differentiator for bringing more magnesium into the application. Driving alternative industries, non-automotive industries, to increase the volume of magnesium availability is a big opportunity. Then, for example, we didn't touch on some other non-automotive applications like mountain bikes. That's where damping is very important, and actually it's a better material choice than your carbon fiber composite, what I've heard from one supplier who makes mountain bikes. Another area is wheelchairs. Having lightweight wheelchairs, because I have, my mom, is more than 90 years old. And when I put that wheelchair in the vehicle, I wish it was made out of magnesium. Then sporting good industries, they can sometimes pay a higher premium for applications. But what it does, it opens the use of magnesium, which makes it then easier for other industries to consider magnesium. So these are my sort of closing remarks. And my paramount always is compelling design. You will be surprised how much that will drive the application of magnesium.
Elmar, do you want to go next, or?
I'm not sure, feel free if you have picked one, but I also have some in mind. Do you like to go ahead?
I was just going to close out by saying, I agree 100% with what Dr. Sachdev was just talking about. When it comes to lightweighting, there's two things, right? When lightweighting for internal combustion-based vehicles is a direct opportunity to downsize the engine of the vehicle, which directly impacts the CO2 out of the tailpipe and increase the miles per gallon, right? EVs lightweighting is super important as well because it's an efficiency play. Cost of batteries as it stands today is very expensive, and the name of the game is range. Anything that helps improve the range of the vehicle is the solution. And if you could do that with less batteries and utilizing more lightweight components, it's very important. But the elephant in the room is the cost of the vehicle itself. So there's a balancing act that every OEM has to play. If it's an EV battery housing, you have to look at it from a mixed material standpoint. You could use a cast magnesium frame, perhaps, and maybe using a steel closeout panel, a composite top panel. There's ways for all materials to have enough room in the vehicle we're talking about over 3,000 pounds of materials in the typical average light vehicle, right? So there's opportunities there. But I think ultimately it returns to supplier diversity and availability, and also reducing the risk of materials itself, right? The raw materials, the tariffs, how easy it is to get to as well too. So I think those are a few closing thoughts I had, but thank you. That's all.
Okay, I think I will pick some of the recycling questions. So I answered a few points of that. So there was the question, for example, about the new European regulations about recycling content, which is getting more and more a requirement that the car makers need to use recycled material, a specific amount of recycled material in their new cars. Let's say currently this can be addressed by, because recycling is not as strictly defined like we might expect it. So from the ISO standards, you can use recycled material which is coming from the production processes. So it's a very short circle. The material hasn't been in use, so it's not really recycling, but as the material is, let's say, rated as a recycled material, it helps to bridge a little bit the lack of availability of end-of-life recycled material at the moment. There are companies which are specialized on the end-of-life sector. Some of them are also, for example, for the European market, they are importing recycled material from Asia, for example, where they have facilities where magnesium is sorted, and so if there is market pull, there are options to deliver recycled materials, but there is a huge room of improvement here. Like I mentioned before, currently, technically it's possible to sort out magnesium, let's say on a alloy level, with the today's LIBS-based sorting systems, but this is not economically it's not economic solution at the moment. So there is not enough market for doing that. There is not enough willingness to pay for that, and so this will maybe change in the next years when it comes to, let's say, regulations which require the use of such material. But let's say regulations typically are used when the market is not adopting by itself. So it's always risky if it's a sustainable system at the end. So it's challenging. We have also some work going on in this area, but there is not really a sufficient answer. If you like to buy magnesium, recycled magnesium, you will find it on the market, but the willingness to pay for this material might not be as high that it's really useful for all kind of applications. So that's maybe, let's say, so a way to answer this.
There's one last question, I think, from the audience that was kind of interesting, and it also piques my interest because I know that there was, I think, in a Cadillac model, there was a vehicle that had a trunk lid sheet made out of magnesium, but I think there was some issues with the paint adhesion or something like that. I don't have answers to that, but do we see more magnesium sheet being used in vehicles in the future at all? I'm curious myself too.
Right. So magnesium, when you go for stamping, so now it enters a stamping world where the stamping generally preferred must have some depth of draw. Mm-hmm. So if you look at the door inner, for example, that has a significant depth of draw for the inner. When you look at the outer, you have to be able to hem it. And that's where becomes a challenge for magnesium both ways, for the outer and for the inner, which is, drawing it over a radius, number one, or hemming it to give a very sharp one thickness hem to give it a what you call a jewel effect when two panels are side by side. And they are both challenging for magnesium. Now, we had made a magnesium deck lid inner, but that was made by superplastic forming. So it's a temperature involved. And you can also hem magnesium by using some sort of temperature at the hem joint. Now, whenever you bring temperature to play, the cost goes up significantly. And so right now, till magnesium sheet alloys are developed, and we have done a big DOE project to demonstrate that you can indeed do some reasonable forming at room temperature. And that was completed about maybe 18 months ago. There's a big report out on that. So technologies are becoming available, but it's very hard to compete with the formability of aluminum and steel. And, aluminum itself has challenges compared to steel. Steel is a highly formable material. And even aluminum has challenges to displace steel for forming, and magnesium has even more challenges. So that's why whenever I look at extrusions and sheet, for example, I tend for automotive to also work hand in hand with non-automotive applications to increase the volume and learnings. So there's a lot of magnesium sheet now used in high-end laptops are all made out of magnesium sheet because forming is a little bit less challenging, but it gives you a very thin component compared to polymer composite. And for high-end laptops, the total thickness of the laptop is measured in microns. When you go to the very high-end laptops, and also for some of the laptops that are very rugged applications, you can get a little bit more strength with a very small increase in thickness of the magnesium. So I have seen many laptops made from magnesium sheet where the compelling driver is the total thickness of the product. So, I would say the world does not stand still, like I have said, and we just need to keep pushing on the supply base. We need to keep pushing on applications everywhere, automotive and non-automotive. And that's the kind of function of the International Magnesium Association, to open these doors and actually forge collaborations between various industries that are not competing with each other, but they benefit by having higher supply base and by having higher base industries that can help all industries. So that's kind of another closing. I've been trying to give closing remarks, but this is kind of the way I see the future.
Thank you very much, Anil, and thank you to our speakers today. And the International Magnesium Association would like to thank all of the attendees as well for taking the time to be a part of this very interesting webinar. Next week, all attendees should receive an email with the recording of the webinar, as well as if you have asked a question in the chat that wasn't answered, a speaker will try to do their best to answer that question in the follow-up email as well. Okay, well, I hope everyone has a great day. Thank you once again. And please be sure to check out www.intelmag.com. That's the International Magnesium Association website for upcoming webinars and more exciting opportunities. Thank you.
Thanks, Rose. Thanks,
Yeah.
everyone. Great job.
Yeah, thank you, everybody.
you.
Yeah, thank you. Thanks to the participants as well. Thank you.
Yeah. Bye-bye.
Goodbye.